Jai Hind to all of you. In this lecture, we are going to study 8255 Programmable Peripheral Interface. This topic is covered under Unit 5 of Microprocessor subject, which is a core subject of Computer Science branch, AKTU, University, Lucknow. So now, first of all, what is Programmable Peripheral Interface and why these are used? So, as we all know that for any microprocessor, the data is normally traveled in parallel mode. Microprocessor normally communicates in parallel. That is, if a microprocessor is of 8-bit like 8085 or 16-bit like 8086, the complete 8-bit or 16-bit data is read or write at a time in a single machine cycle. So, to direct data in either in parallel mode or serial mode, we require programmable peripheral interface, which is required to basically transfer data from microprocessor to external world and vice versa. So, programmable peripheral interface is a general purpose programmable device which is used for data transfer between microprocessor and I/O devices. Basically, it is connected between microprocessor and I/Os. These devices are not directly connected to transfer data either in serial mode or in parallel mode. So basically, 8255 has three programmable I/O ports named as port A, port B and port C, and these ports are operated either in or out, like example to read or write data. So these ports can be used for unidirectional or bidirectional data transfer with the help of control word that is defined in control word register. So these three ports are operated in I/O mode or BSR mode. In case of I/O mode, it is further divided into three modes, that is mode 0, mode 1 and mode 2. And in case of BSR mode, it is used to set or reset the bits. First of all, the pin diagram of 8255. 8255 IC consists of 40 pins, in which 3 ports are used, which each consisting of 8 pins, that is port A, B and C. Port A pins are from PS0 to PS7. Port B pins from PB0 to PB7 and port C pins consist of PC0 to PC3, that is lower port C, and PC4 to PT7, that is upper port C. We have used bifurcated port C into two parts because one port half is used with port A to provide control signals and the other half is used with port B to provide control signals. Then the next bits, the 8 bits are data bus bits. The data bus of microprocessor is connected to this D0 to D7 pins. So these total are 8 into 4, that is 32 pins. 2 pins are used for supply, that is VCC and ground, and the remaining 6 pins are used for control signals, that is read, write and so on. So this is the pin diagram of 8255 IC. The port A moves from PA0, 1, 2, 3, 4, 5, 6, 7. That is pin number 1, 2, 3, 4 and 37, 38, 39, 40 are for port A. Similarly, port B pins are 18, 19, 20, then 21, 22, 23, 24, 25. So PB0, PB1, PB2, 3, 4, 5, 6, 7, that is pin number 18 to 25 are reserved for port B. PC0 to 3 are used with port B. So these are in sequence with port B, whereas PC4 to 7 are used with port A. Next, 34 to 27 are used at data bus pins D0 to D7. Pin number 26 is VCC. Pin number 35 is reset. 36 is write bar. Here in the left side, pin number 8 and 9 are connected to lower order address bus pins. Address bus consists of 16 bit for 8085 and 20 bit for 8086. So the LSB 2 pins A1 and A0 are of address bus are connected to A1 and A0. Pin number 7 is ground. And 5 and 6 are read bar and chip select. So these are all the pin configurations of 8255 Programmable Peripheral IC, where PA0 to PA7 consists of 8 pins. This port can be configured either in input or output with the help of programming. Similarly, PB0 to PB7, that is 8 pins. This port can be programmed as output latch buffer or input buffer and can also be programmed in mode 0, mode 1 and mode 2. We will see later on what is meant by these modes. PC0 to 7 consists of 8 pins which can be programmed either in bit set or reset mode, that is BSR mode. This can be divided into two 4-bit ports, that is PC4 to PC7 and PC0 to PC3. One group is used with PB to provide control signals, port B, and one is used with port A to provide control signals. So PC7 to 4 are used with port A and PC0 to 3 are used with port B, as we have already seen this in the diagram. PB, this is used for port B and these are used for port A. Next is D0 to D7, that is data bus. This is used for data transfer between microprocessor and IO devices. This transfers the control to PPI and read status information from PPI. Chip select bar, it is an active low signal, and when this terminal is 0, this means the data transfer between PPI and microprocessor is possible. Unless GLCS bar is 0, this 8255 is not selected. The data bus is placed in high impedance state and the control from the processor is ignored. Read bar and write bar are also active low pins. Read bar is used for read operation and write bar is used for write operation. A0 and A1 are used to select. These are the lower order 2 bits of address bus of microprocessor and used to select port A, B, C and control register respectively. Reset is used to reset all internal registers including control register. When it is equal to high, that is active high signal, it will reset all internal registers including control register. All ports are placed in input mode of mode 0, that is high impedance state. VCC is connected to 5 volt and VSS is connected to ground. So this is the overall block diagram of 8255 PAY. It consists of port A, which consists of group A plus port C upper bits, PC4 to PC7. Similarly, group B consists of port B plus port C lower, that is PC0 to PC3. These are connected in bidirectional way to system bus, and port A plus PC4 to 7 are controlled using group A control. Similarly, port B and PC0 to 3 are controlled using group B control. So group B controls PC lower plus PC PB, group A controls PC higher plus port A. These two groups and the system bus is connected through data bus buffer, which is connected to bidirectional data bus of microprocessor. And these two group controls are controlled through read-write control logic, which consists of read bar, write bar, A1, A0, reset and chip select, that is 6 control signals. So this is the overall diagram, which consists of 8-bit port A, B and C, that is 8 into 324, plus 8 data bus, that is 32 pins, plus 6 control pins, that is 38, and 2 supply, that is plus 5 volt and ground. So the basic operation of this 8255 depends on the combination of chip select, read bar and write bar. And A1, A0 is used to select port A, B and C. When A1 and A0 is 0, 0, it selects port A. When it is 0, 1, it selects port B. When it is 1, 0, it selects port C. And when it is 1, 1, it selects control register. So this is the mode control. So from the rightmost two column, A1, A0, 0, 0. Chip select 0 means the chip is selected. And read bar is 0. So the port A data is read to data bus. Similarly, when 0, 1, then port B is read to data bus. And when it is 1, 0, port C value is moved to data bus. That is, read operation is performed. So the input device is used as an input port. Similarly, when write bar is 0, the data bus value is written to port A, B and C respectively. And when this is 1, 1, the same value goes to port C. That is, the data bus value will move to control register in case of I/O, output and all the modes. So group A and group B gets the control signal from processor and send the command to individual control blocks. For group A, the control signals are provided by PC4 to 7, and for group B, the control signals are provided by PC0 to PC3. So now we will move with the control word format. The control word format for I/O mode are as shown here. The MSB, that is D7, will define whether it is programmed in I/O mode or BSR mode. When it is 1, then this 8255 works in I/O mode, and when it is 0, it works in BSR mode. The next 4 pins are used for group A. D3 will define port C upper bit, 1 for input and 0 as output. D4 will define port A, 1 for input, 0 for output. And D5 and D6 are used for mode selection, that is 0, 0 for mode 0, 0, 1 for mode 1 and 1, 0 or 1, 1 for mode 2. The next 3 bits are used for group B. D2 will define whether it is in mode 0 or mode 1. D1 is used to define port B whether as input or output, and similarly D0 is used to define port C lower whether as input or output. So this is the control word mode format for I/O. Now we talk about the operating modes, that is I/O. 8255 operates in 2 different type of modes, as we have already told, that is I/O mode and BSR mode. In case of I/O mode, it works in 3 different modes: mode 0, mode 1 and mode 2. So there are 3 basic modes of operation in I/O mode, that is mode 0, which is basic I/O data transfer using group A or B. Mode 1, that is strobe input or output data transfer using group or B. Strobe is called as handshake data transfer. And in case of mode 2, it is used as bidirectional data transfer, that is 2-way data transfer using port A only. So the operation modes for group A and group B can be independently defined with the help of control word, the format for which is defined in this slide. If D7 is equal to 1, Then it is works in IO mode. And if we write a control word into PPI, which defines the operating mode selected. And when D7 equal to 0, it works in bit set reset mode, which set or reset the bits of port C. So in BSR mode, port C bits can be set or reset by sending the instruction to the control register. So now we will move towards mode 1, that is handshake or strobed interrupt IO data transfer mode. In case of mode 1, input or output of port data is performed. IO using port data is performed in conjunction with strobe or handshake signal, that is control signal. And port C bits are used for control or handshake. So when input device has data to send, it checks input buffer full is 0. If 0, it sends data on PA027 or PB027 and activate strobe signal to show data. When strobe goes high, data enters the port and IBF, that is input buffer full, gets 1. If the port is interrupt is enabled, INT is activated and this interrupt the processor. The processor read the port during interrupt service sequence and then IBF and INT gets deactivated. So this is the port diagram. In case of mode 1 port A, PC4 is used as a strobe signal, active low, PC5 as input buffer full, PC3 as interrupt INTR, PC6 and 7 as simple IO pins, and INTEA is internal. Similarly, for port B, PC2 and 1 input buffer full and strobe, PC0 as INTR. So the overall control word consists of D7-1, that is IO mode. For input, mode 1, that is 0-1. D4 equal to 1, that is in input mode, and D3, that is control bits 1/0. So 6, 7 in, 0 as output and 1 as input. Similarly, for port B, these 3 pins are used on cross for port mode A. And to write control word for port B, we don't care these 4 bits and write 1 and 1 for port B as in mode 1 as input. So INTEA and INTEB are controlled by BSR of PC4 and bit set reset of PC2 respectively. This is the timing diagram. When strobe input is active low, that is once the handshake signal comes, input buffer, the data is transferred to port, input buffer will become active high. After that, it send the interrupt request. The data is read from the port and will be transferred to the processor. So this is the handshake input mode. Similarly, this is the handshake input interrupt output port. When output device want to receive data, it checks OBF, output buffer full signal is 0. If 0, it receives data on port B and activates acknowledgement signal. Acknowledgement is active low signal. When acknowledgement goes high, data goes out of the port and OBF is set to 1. If the port interrupt is enabled, INT is activated. This will interrupt the processor. So the processor sends another byte to the port during ISS and OBF and INT are reset to show that the data is sent at the output port. So in case of mode 1 output mode, previously similarly as we have seen for input mode, when port A is used at output, PC6 and 7 is used for acknowledgement and output buffer full, PC3 for INTR and 4 and 5 for simple IO data transfer. Similarly, if we use port B, then PC2 and 1 for acknowledgement and OBF, PC0 for INTR. So when we see the mode word, this is for IO mode, this is for mode 1, port B as output, so it is 0, and these are control signals, so 1/0. And these 3 bits are for port B, so don't care. Similarly, for port B, 1 for IO mode, next 4 bits are don't care, then mode 1 and output, and this is input/output. So INTA and INTB are used by PC6 and PC2 respectively. Similarly, in mode 2, it is used as bidirectional operation, that is bidirectional data transfer. For bidirectional, port A is used as 8-bit bidirectional bus for data transfer. This bidirectional mode is used only to group A. And in case of when the group A is programmed as for bidirectional data transfer, 5 control signals, that is higher order 5 bits of port C, PC3 to 7 are used by port A. In this case, the port A works both as input and output. And when group port A is set in mode 2, group B can be independently set either in mode 0 or mode 1. And the remaining 3 controls are used by port B. So this is the control word in case of port A in mode 2 IO, that is bidirectional, and port B as mode 0. So D7 pin works as 1, which shows IO mode. Then D6 and D1 cross shows mode 2. And since input and output both, so it works as don't care. Similarly, since port B in mode 0, so it is 0. Mode 0 input, so this pin is 1. And this is a control, so 1/0. So this is the control word for this combination. Similarly, if we have to write port A, mode 2 IO, we can easily write it as in IO mode, so D7 is 1. Then mode 2, so 1 cross. IO mode, so other 2 pins are cross. Then mode 1, so 1. Output, so next pin is 0, and then don't care. So we can easily write any control word using the set criteria. So this is the operating example in mode 2. PC3 is used as INTR A, interrupt request for port A, OBF A, acknowledgement A. Then PC4, 5 are used for strobe and IBF for port A, that is input output. And 0, 1, 2 are used for simple IO data transfer. So in case of write operation or read operation, write bar is used, then output buffer full, then INTR, and this way the data is available at port A, input and output both at the same time. And hence write bar and read bar signals both are used in case of bidirectional data transfer. So mode 2 bidirectional consists of INTR, interrupt request, which is an output that requests an interrupt. Output buffer signal is also an output, indicating that output buffer contains data for bidirectional bus. Acknowledgement is input signal that enables tri-state buffer. Strobe input is used to load data into port A. Input buffer full is an output which shows that input contains information. INT, that is interrupt enable, are internal bits that enable INTR pin. And PC0, 1, 2 are port C, general purpose IO pins that are available for data transfer. Now for BSR mode, it is used to set or reset port C bits only. Port C consists of 8 bits. D7 is used, which is 0 for BSR mode. Next 3 bits are don't care, that is D6, D5, D4. Next 3 bits are used to select the bit of port C, that is 000 for bit 0, 001 for bit 1, and so on. Similarly, to make it value 0, it will be reset, and 1 so set. So if we have to make PC 60, considering an example, so we write the control word will be 0, then next 3 bits are don't care. To select PC6, next is 110, and last is 0. So to reset PC6, the required control word is 0, 3 don't care. Then for 6 it is 110, and to make it 0, that is last bit will be 0. So the control word for both mode is same. D7 is used to specify whether word loaded into BSR mode or is in BSR mode or IO mode. When D7 is 1, it is in BSR mode, otherwise IO mode, otherwise in BSR mode. PC 0 to 7 is set or reset as per value of D0. A BSR word, for example, if we have to set PC3, then it is 0, 3 don't care. To set value 3, 0, 1, 1, and to set it is 1. So this is the control word for set of PC3. Similarly, if we have to set reset PC4, we all can see D70, next 3 don't care. For 4 it is 100, and to reset it is 0. So this is the control word. Here access don't care. So thank you. We have already seen 8255 PPI in various modes. The application of PPI, that is to transfer data in various modes. Then various operating modes, block diagram and pin diagram of PPI. We have also seen how to transfer data in simple IO mode, handshake mode, and bidirectional mode. And at the end, we have seen how to set or reset PC, that is port C bits of 8255. So we will continue our lecture in next slides and will study some more peripheral devices, that is 8237, 8279, and 2 more peripheral devices to be used with microprocessor.